Hello everybody! The topic of this section is the basic building blocks, pure discount bonds. In this section, we will discuss how to take account of the fact that generally the yield curve is not flat. That is, the interest rates vary with maturity. First, let's see what are the pure discount bonds. Pure discount bonds, also called zero coupon bonds, are bonds that promise a single payment of cash at some date in the future, called the maturity date. Pure discount bonds are the basic building blocks for valuing all contracts promising streams of non-cash flows. The promised cash payment on a pure discount bond is called its face value or par value. The interest earned by investors on pure discount bonds is the difference between the price paid for the bond and the face value received at the maturity date. The yield or interest rate on a pure discount bond is the annualized rate of return to investors who buy it and hold it until it matures. For example, for a pure discount bond with a face value of $1,000, maturing in 1 year and a purchase price of $950. The interest earned is the $50 difference between the $1,000 face value and the $950 purchase price. The yield on this 1 year pure discount bond is expressed as face value minus price over price. The face value is $1,000. The price is $950. So the yield is equal to 1,000 minus 950 over 950 is 5.26%. If the bond has a maturity different from 1 year, we would use the present value formula to find its annualized yield. For instance, suppose that a 2-year pure discount bond with a face value of $1,000 and a price of $880. In the present value formula, the PV is the price, $880. The FV is the face value $1,000, and the number of years is 2. So 880 is equal to 1,000 over 1 plus I to the second. Solving this equation, the yield I is obtained as 6.6%. Return to the valuation of security of the former section that promises to pay $100 each year for the next 3 years. Suppose that we observe the set of pure discount bond prices in the following table. Following standard practice, the bond prices are quoted as a fraction of their face value. There are 2 alternative procedures that we can use to arrive at a correct value for the security. The first procedure uses the prices in the second column of this table, and the second procedure uses the yields in the last column. Procedure 1 multiplies each of the 3 promised cash payments by its corresponding per dollar price and then adds them up. PV is 100 multiply 0.95 plus 100 multiply 0.88 plus 100 multiply 0.8. The resulting estimate of the security's value is $263. Procedure 2 gets the same result by discounting each year's promised cash payment at the yield corresponding to that maturity. 100 over 1 plus the yield on the 1-year maturity 5.26% to the first, plus 100 over 1 plus the yield on the 2-year maturity 6.6% to the second, plus 100 over 1 plus the yield on the 3-year maturity 7.72% to the third. Can we discount all 3 cash flows using the same 3-year yield of anyone listed in the third column of the table. If we do so, the results would be mistake. Is there a single discount rate that we can use to discount all 3 of the payments the way we did in the formal section to get a value of $263 for the security? The answer is yes. Substitute the 3 yields for I in the formula for the present value of an annuity in the procedure 2 and solve this equation. The single discount rate is obtained as 6.88%. Note that the present value, $263, is calculated by using the above 2 methods, and we have no direct way to find the value of the 3-year annuity using a single discount rate with the bond price information available to us in formal table. We can summarize the main conclusion from this section as follows. When the yield curve is not flat, that is, when observed yields are not the same for all maturities, the correct procedure for valuing a contract or a security promising a stream of known cash payments is to discount each of the payments at the rate corresponding to a pure discount bond of its maturity, and then add the resulting individual payments values. Finally, let's do a quiz. Suppose the observed yield on 2-year pure discount bonds falls to 6% per year, but the other rates reported in formal table remain unchanged. What is your estimate of the value of the 3-year annuity paying $100 per year? What single discount rate applied to the present value formula for annuities would give this same value? The estimated value of this annuity is equal to the present value of an ordinary annuity with annual payment $100 discounted at yield corresponding to its maturity. The specific formula is as follows, and the estimated value is obtained as $264. For the single discount rate, substitute the 3 yields in above equation for parameter I, and solving this equation, the single discount rate is 6.674%. In summary, we have studied what is pure discount bond and tried to calculate the value and the yield of this bond. For a pure discount bond with different yields on different maturities, we discussed how to calculate its value and the single discount rate. That's all about this section. Bye.